This last piece that we're going to do is the sequencing piece. And so we're going to do a little bit of sequencing with this first example. So it says apply the indicated series of transformations to this rectangle. Each transformation is applied to the image of the previous, not to the original. So it's going to, after we do and we get a new one, then we'll use that one to do the next one and that one to do the next one and so forth. You're going to label each image with the letter of the transformation applied. All right, so I'm going to use colors to go from the next one and do really well labeling. So starting with A says XY is going to become X plus 7 and Y minus 2. So that is a translation. So we're going to translate, and X plus 7 means right 7, and Y minus 2 means down 2. So I'm going to take each of my points and go right 7 and down 2. So I'm going to start with this first one over here, and I'm going to go right 7. 1, 2, 3, 4, 5, 6, 7, and down 2, 1, 2. There's my new coordinate. I'm going to do this one now. So right 7, 1, 2, 3, 4, 5, 6, 7, and down 2, 1, 2. Same thing again. Right 7, 1, 2, 3, 4, 5, 6, 7, down 1, 2. And my fourth corner, right 7, 1, 2, 3, 4, 5, 6, 7, down 1, 2. So here's my new figure, and this is after a translation of X plus 7 and Y minus 2. So then we're going to put the letter A on the inside to show that this was after A. All right, B says XY is going to become X, then opposite Y. So notice X and Y are in the same position, but Y became its opposite. So which rule was that? Well, it's a reflection, but which axis has the reflect where the Y changes to its opposite? That's the X axis. Reflect across the X axis. All right, so that's what we're going to do next. We're going to take each point and count how far it is from the x-axis, which is your horizontal. So we're going to go down 1, 2, 3, 4, and then go 1, 2, 3, 4 on the other side and draw our new location of this point. All right, this one is 1, 2, 3, 4, 5, 6 away. So we're going to go 1, 2, 3, 4, 5, 6 away on this side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the last point, 1, 2, 3, 4. 1, 2, 3, 4. So this is my new rectangle after it has been reflected across the x-axis. So this gives the letter B. C says rotate 90 degrees clockwise around the origin. So we're going to rotate B 90 degrees clockwise. All right, so a clock, remember, always turns to the right. So we're going to go from quadrant 4 to quadrant 3, 90 degrees. All right, so let me write down my original coordinates here. So this point right here is at 1, down 1, 2, 3, 4. So it's at 1, negative 4. So I'm just going to write that here to the side. It's at 1, negative 4. My next ordered pair is at 1, negative 6. This ordered pair is at 1, 2, 3, 4, 5, down 1, 2, 3, 4. So 5, negative 4. And then this bottom point is at 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6. So 5, negative 6. All right, so we're going to use our rule for 90 degrees clockwise. What was our 90 degree clockwise rule? All right, so take your paper and look at your notes for your 90 degree clockwise rule. All right, so we know X and Y are going to switch positions, so Y comes first and X becomes second. Which one switches to their opposite? It is the X value, so Y opposite X. All right, so the Y value is going to come first, so negative 4. And then this X value is going to go second and change to its opposite, so that'll be negative 1. All right, let's do the next one. 1, negative 6 is the original, so then we're going to switch them. So the negative 6 will come first, and then the 1 will go second and become its opposite, so that's -1. We're going to be doing this one, so -4 is now going to come in the front, and 5 will go second and become its opposite, so that's -5. And the last one, -6, moves to the front to the x value position, and 5 moves to the second, and it becomes its opposite, so -5. So now I'm going to graph those points. So we're going to go -4, so left 4, and down 1. We're going to go -6, so left 6, and down 1, -6, 1. That's this one. All right, this one's -4, -5, so we're going to go left 4 and down 5. And then -6, -5 would mean left 5. 1, 2, 3, 4, 5, 6, left 6, sorry, and down 5. 1, 2, 3, 4, 5. And here is rectangle C after a 90-degree clockwise rotation from here. So from B, 90 degrees clockwise rotation becomes here. All right, D, we're going to add 5 to the x value and add 3 to the y value. So this will be a translation. So translate. X plus 5 means right 5. And y plus 3 means up 3. So we're going to take each of these points and count right 5 and up 3. So I'm going to go right 1, 2, 3, 4, 5, up 1, 2, 3. Right 1, 2, 3, 4, 5, up 1, 2, 3. Right 1, 2, 3, 4, 5, up 1, 2, 3. And this one, right 1, 2, 3, 4, 5, up 1, 2, 3. All right, so here's my new rectangle D. And E, the rectangle for E, I'm going to switch colors for this one. I'm going to go to purple. Has 3x, 3y. So that means you're multiplying the x by 3 and the y by 3. So this one is a dilation with the scale factor of times 3, so the scale factor is 3. So that means each of these original ordered pairs is going to get multiplied by 3. So let's find the ordered pair for this first corner. It says this one's at 1, 2. So 1, 2. We're going to multiply each of those by 3, so that becomes 3, 6. So I'm going to go right 3, 1, 2, 3, and up 6. 1, 2, 3, 4, 5, 6. So here's my new point for this corner. All right, I'm going to do this one, which is -1, 2. We're going to multiply each of these by the scale factor of 3, so this becomes -3, 6. So we'll start at 0, 0, go left 3, and up 6. All right. This point is at 1, -2. All right, so multiplied by scale factor of 3 becomes 3, -6. And I'm going to go start at 0, 0 and go right 3, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. And the last point is over here, which is at -1, -2. So that changes to -1 times 3 is -3, -2 times 3 is -6. So -3, -6. So left 3, down 6. All right, and so my last rectangle is going to be 3 times larger than the previous one. So each side is 3 times bigger, and you can count to see that. The original rectangle D was only 2 units, and now it's 1, 2, 3, 4, 5, 6. 6 units. So this is rectangle E. And I just made a big E in the middle, so that you know. All right, and the last one says, give the coordinates and vertices of E, which I already did right here. That's how I knew where it would be. All right, so the last thing we need to talk about is the size and shape. Okay, so I'm going to answer these last 3 questions. It says, compare rectangle E to the original. What do we know about the shape? Well, the shape of the original rectangle up here, the black one, and this purple one that I just drew, they are the same shape. What about their size? Their size is different. They are the same shape but different size. And what about the angle measures? Well, this angle up here in the original is 90 degrees. This one's 90, and this one's 90, and this one's 90. And then in my purple rectangle, all the angles are also 90. So the angle measures, even though the figure got way bigger, the angles didn't change. They're still the same. So E-R-E-N-T. Sorry, I butchered that. E-R-E-N-T. So we know that these are going to be similar figures. They are the same shape but different sizes, and all the angles are still the same. So when you dilate, it creates a similar figure, but all the red ones are all congruent. So translations, reflections, and rotations create all congruent figures. When you dilate, that's the only one that makes it similar. All right, great job. There, you're done with your lesson now.